Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Amir Azhari bin Azmey and I'm from AS2295B, and today I want to present to you about my final year project, which is noise exposure in residential area, Seksyen 8 Shah Alam. Okay, for the introduction, there has been studies from Segaran in 2020, and he stated by World Health Organization that noise pollution is the second most dangerous pollutions in the world. So it has become a significant issue for us, human people. But before all that, what is noise? Noise is an unwanted sound, and for your understanding, it is a sounds that present in the wrong moment, wrong time, and a wrong place. Okay, as you know, Malaysia is one of the developing countries, and the problem for these developing countries is the constantly occurs with the increasing number of road transportation networks in supporting the development process. And if there is a sound pollution, this can cause sound pollution, and if there is a sound pollution, it can be a effect for us, and also we can take a significant measure so we can prevent this from happening. Okay, what is the problem statement in these studies? As I said that noise pollution is the second most dangerous pollution. It is because despite the awareness, there is a limited research on this noise exposure, specifically in Malaysia residential areas. And the urban and suburban areas of Shah Alam, which is my location of this project, face a pressing challenge of escalating noise growth and increasing in vehicular activity. This is because Shah Alam had become the main city for other city to pass through, and the residents are increasingly subjected to elevated noise level, primarily from road traffic. Okay, so there is three objective for the study, which is the first one is to identify the noise exposure level in the residential area. The second one is to determine the traffic volume in the section 8 residential area, and lastly to analyze the relationship between the noise exposure level and traffic volume. For the literature review part, there is three literature that I've been taken for my reference, and this is the main reference for my studies. Of course, there is a lot of more article that I use, but this is the main article. So we can see that among these three article, all of the article has a impact of noise pollution to us human. As you can see, the first article, there is a negative long-term influence on people health, which is study, sleep, rest, and communicate with one another. Okay, the second article also there is a impact, which is it can cause speech disturbance and hearing loss. And of course, the third, there is also the what we call it, the effect for us, which is the ischemic heart, and this is more chronic other than other effects. And we can see that all of this data, there is just one article which below the OE standard, which is 65 dBA. Okay, this is the schedule that I use for my reference, and this schedule is from permissible limit of noise exposure level, Department of Environment in 2017, and I use the second schedule. And for me, for my study location, Shah Alam Seksyen 8, it included in the suburban and urban residential area mixed development. So my standards is 65 dBA. Okay, for the research methodology, there is the three objectives. So I have three research methodology. The first is I use sound level meter to identify the sound exposure level. The second method, I use the clickers to count every vehicle that passing through the sound level meter to determine the traffic volume. And lastly, to analyze the relationship, I use SPSS software, and I use in the SPSS software, I use Pearson correlation coefficient because it is the most suitable way to find the relationship between these two variables. Okay, this is the sampling location, and as you can see, one location, I have three different location, and every location I make it two stations so that I can get more accurate result. and also I've included the coordinate of each location, and the timing I do it in the morning peak hour and afternoon peak hour. Okay, this is the data for my first objective. As you can see, there is 3 location, and every location there is 2 stations, and of course there is a morning peak hour and afternoon peak hour. Actually, I want to do for the evening peak hour also, but due to the bad weather, I can take the measurement at the locations because it will disturb my data. Okay, this is the first objective data for my first location, and as you can see, from 7 a.m. to 8 a.m. it is the highest value of LAEQ. This is because during the sampling, there is a construction at the house near my sampling locations, and all of this time it is below the DOE standard, which is 65, and this place is very far from commercial area, so the noise exposure level is below the DOE standard. Okay, the data for my second location, but in the first objective, we can see that the first graph, which is 7 a.m. to 8 a.m. had exceed the DOE standard. This is because the sampling location that I take is near with the commercial areas and near with the Masjid Al Rahmah. So this is for the variability of my data. So as you can see, the highest maximum noise that counted is 83.5. This is because there are a lot of lorry, a lot of bus, and the amount of car is higher compared to the 2 places. This is the data for my third location, which is Jalan Tepuan, and as you can see, all of the LAEQ for all of the time is still below the DOE standards, and the highest is 57.8 during morning peak hour 8 a.m. to 9 a.m. This is because the place is far from the commercial area, and this place is a student's rent place, so it quieter compared to the second place. Now we move to the second objective, which is traffic volume. We can see that the table above show the data for the second objective, traffic volume, and I've classified it to 5 type of vehicle, which is car, van, motorcycle, lorry, and bus for the 3 different locations. Okay, this is the first data of my second objective. The first location is Jalan Mendapan, and we can see that the highest amount of car is in the morning peak hour 7 a.m. and 8 a.m. and we can see that there is no lorry at all from that time and from the other time, but there is a lorry but has no bus. So the higher type of vehicle, the 2 highest type of vehicle is car and motorcycle. For the Jalan Liku, as I mentioned that the location for Jalan Liku is near to the commercial areas, so the amount of car, vehicle, and other type of vehicle is of course higher compared to the 2 places, and we can see that there is a lot of difference from this location compared to the 2 other locations, and there is a lot of lorry, and there is 1 bus from at 12 p.m. to 1 p.m. and this can contribute to a loud noise compared to the 2 different places. For the third location, Jalan Tepuan, of course the higher type of vehicle is a car, and among the morning peak hour and afternoon peak hour, the highest is from the morning peak hour because there's a lot of people go to work and go to class also, because it is a place for students, and we can see that from 8 a.m. to 9 a.m. there's a lot. It is the highest data for motorcycle value. Now we move to the third objective, which is the relationship. I use SPSS Pearson correlation because it is the most suitable, and as you can see, this the data for morning peak hours. The Pearson correlation coefficient value for the morning peak hour is 0.996 and 0.798. and this is a highly positive value that indicate there is a positive relationship between noise level and traffic volume. The higher the traffic volume, the higher the noise level in that area. This is the data for afternoon peak hours, and as you can see, it is a highly positive significant value, which is 0.980 and 0.992, which indicate there is a highly positive relationship between noise level and traffic volume. Okay, in conclusions, among of all the three different location and among of all the stations that I measure, there is just one places at the 1 hour time, which is Jalan Liku from 7 a.m. to 8 a.m. The only time and places that exceed the DOE standard, which is 65, and we can see that from the third objective, high positive relationship between the noise exposure level in section 8 residential area can affect the traffic volume, and vice versa. Okay, there's two things that I recommend for reducing the noise pollution or noise exposure level. The first is traffic calming measure, such as speed bumps, roundabout, and narrow railway. This recommendation can reduce the traffic volume, and if the traffic volume is reduced, of course the noise pollution will reduce also. And the second is deploy an intelligent transportation system (ITS) technologies. This measure also can reduce the traffic volume, and it can enhance the traffic efficiency and reduce the noise. Okay, that's all from me. Thank you for your time, and thank you for your attention. I appreciate it so much. And I'm Amir Azhari bin Azmey. Thank you for